Dear students, I am Dr. Vikramadityan. I am a professor. I am going to give an elaborate series of lectures as a video on theory of computation. In this particular video lecture series, we will discuss more about some fundamentals of theory of computations and finite automata or finite state machine, push down automata, Turing machines, and many other topics. Continue watching this particular video lecture series. Let us enter into some introduction. Theory of computation, or sometimes we call it as automata theory and computability, and even we can call it as finite automata and formal language. This all stands same. Automata means in Greek word a study of abstract computing device or a computing machine which works by itself. In 1930, Alan Turing, a scientist, studied an abstract machine that has capability to do all computations similar to present systems. We call that particular abstract machine as Turing machine. When you say, I have completed theory of computation means you should be strong enough to design this Turing machine. So, at the end of our video lecture series, we will be giving more detail about Turing machine. In general, any algorithm you implement in C program, Python, Java, you should know how to implement the same in Turing machine. Chomsky in 1950, basically he is a linguist, he gave the study of grammars and how its importance in designing a compiler even in today's world. Mr. Cook in 1969 extended this Turing machine's study, that is Alan Turing study, as if you define a computer or if you define a machine, what it can compute, what it cannot compute. That is what he studied. What is theory of computation? We call it as TOC. Is fundamentals of computer science that focuses on the nature, compatibilities, and the limitations of computational systems. If you have a computational systems, it will tell what is its nature, what is its properties, what is its capabilities, what are their limitations. This subject also investigates how problem can be solved mechanically using algorithm, or if you say there is an algorithm, how that algorithm can be implemented can be studied in our theory of computation subject. It defines mathematical models needed to perform these calculations. Why to study this automata theory? It is one of the core part of our computer science. If you say I am a computer science student, you should know the theory of computations. What is its application? The entire modern computing machines, whatever you say, sir, there is a problem. Algorithm exists. Then better you implement that algorithm using these computing machines, especially Turing machines. Design and development of modern software, automated hardware system, and compiler design in today's world stands on the one and only word TOC, that is theory of computation. Finite automata, or we can also call it as finite state machine, is a mathematical model of a computation. I will just give a simple example, just a switch. It is having an on, it is having an off. Just in our home or in our office, we do have a switch. It is having a two states. One is on state and the other one is off state. When we do pressing this particular switch, its states changes. How to represent mathematically? There is a switch which is in off state. Now let us consider that as the initial state. When I do push that particular switch, it will change its states to on. Again when I push, it will change its states to off. That's all. In real world, you might have seen the switch. I am bringing a mathematical model for that particular switch. Now what are the parameters in this particular diagram? It is having a circles. We call it as a states. There are some arcs. We call it as inputs to the states. We do have inputs to the external influence, that is push. Okay, they are all the inputs. We mentioned start state here, that indicates this is the initial state of the system. We do have a double circle here that indicates this is the final state of the system. It is having a two state. One is off state, other one is off state. Totally it is a finite. So we call it as a finite state machine or finite automata. What is a finite state machine? It is a mathematical model of a computation that describes a system with a limited number of states. In the previous example, we discussed two states. Transition between them based on input. The input here is the push. We define broadly into two categories, that is deterministic finite automata and non-deterministic finite automata, that is DFA and NFA. In non-deterministic finite automata, we extend our studies to epsilon NFA, that is where there is no input. We call it as a epsilon NFA, that is called epsilon non-deterministic finite automata. With this simple introduction about finite automata and finite state machine, I would like to conclude this particular lecture on introduction to TOC. In the next video, we will discuss about more problems on finite state machine. Thank you.